Hello, this is video four on my series on insulin resistance. And I thought I might talk a little bit about what insulin is and what insulin resistance really is and how it affects the propensity to weight gain and obesity and type 2 diabetes. So insulin is a hormone, and a hormone is a messenger, like a chemical messenger that is produced by an organ. It can also be produced from different types of cells. Muscle cells produce hormones, fat produces hormones. Hormones can also, chemicals can have multiple functions. The body is very clever and conserves function that way. So a neurotransmitter, which is a brain chemical messenger, can function as a hormone in different parts of the body, and hormones can function as neurotransmitters in different parts of the body. So basically, a hormone is a chemical messenger produced by usually organs. And a chemical messenger can act on the organ itself, which is, or on the cell that the cell that produces the hormone can turn back around and act on the cell itself, and that's autocrine. Or it can act on nearby cells, and that's paracrine. Or it can act on cells and organs distal or far from itself, and that's called endocrine. So autocrine, paracrine, and endocrine, and you've probably heard of endocrine and endocrinologists and the endocrine system. So that basically means hormones that act at a distance from the organ that was produced. So insulin is a hormone produced by the pancreas, and the pancreas is a digestion organ just behind the stomach, and it produces enzymes and hormones to help with digestion and to help with dispensing the nutrients to where they need to be. So it produces a bunch of hormones that help with digesting proteins, proteases, fats, lipases, and it also produces insulin. And so when you break down particularly carbohydrates, you break them down into their individual sugar molecules. And then once they're broken down into their individual sugar molecules in the gut, they pass to the bloodstream, and then from the bloodstream they travel to the cell. But the cell is locked by is locked. The cell receptor is locked, and so therefore the insulin has to come along and attach to the receptor of the cell and open it up and let the sugar go into the cell. And once the sugar's in the cell, as I said in a previous video, it has three destinies. It gets converted into energy, it gets stored as fat, or it gets repackaged as human starch in the form of glycogen. So long chains of the sugar molecules. And then I talked a little bit about how insulin resistance is when the receptor doesn't respond very well to the insulin. So some people have inherited a propensity to have the receptor not respond very well to the insulin, so that the body has to produce large amounts of insulin. And the side effect of large amounts of insulin is that it puts the body into this fat storing state, okay? And that's kind of a good thing, because what it is that's the way it does that is through selective insulin resistance. By having the muscle and liver cells somewhat resistant to insulin, and so the sugar can't enter the liver and muscle cells, the pancreas has to produce large amounts of insulin to overcome that. But the organ that stays sensitive to insulin is the adipose tissue, or the fatty stores. So despite the fact that the insulin doesn't act on the receptors of the liver and the muscle very well, and you have to produce large amounts of insulin to overcome that, the fatty tissue remains sensitive to insulin. So you can continue to store fat in response to insulin. You can continue to convert sugar into fat and store it. So that's why having that kind of resistance in the liver and the muscle is a helpful thing for putting on weight, because those large amounts of insulin encourage fat storage in the fatty tissue. And that's useful if there's a huge requirement for those fatty stores coming up, such as a famine, or a drought or a nutritional challenge like a big sea voyage, or you're going on a big hunt, or you're having a season of very high activity doing gathering or agriculture. So having that ability to produce large amounts of insulin because your receptors are sensitive, are resistant, and then having those large amounts of insulin act on the fatty tissue to push the fat into the fatty tissue because the fat remains sensitive to insulin. That's selective insulin resistance. So what happens in type 2 diabetes? What happens is that unlike in the state where you would have these counterbalancing famines and droughts and sea voyages and hunting expeditions, we have an unlimited amount of access to food and don't need to move much. So our pancreas ends up having to produce insulin. We end up storing fat, and the side effect of that fat is your cells and your liver and your muscle become even more resistant to insulin. And the side effect of having cells that become even more resistant to insulin is you've got to produce even more insulin. And so as a result, eventually your pancreas cells become fatigued and they can't release enough insulin to cope with, and you end up with sugar building up in the bloodstream, poisoning your body, and you become type 2 diabetic. And so I'm recapping what's been said. Now, interestingly, because insulin resistance is good for you in the sense that it's good for you if you are in a lean environment, there's been research showing that particularly native populations in Australia, people in India, native populations in the Americas have high levels of insulin circulating in their system. Even lean, slim individuals have high levels of insulin circulating in their system. When there wasn't too much excess nutrition to go around, those high levels of insulin didn't make you fat because there wasn't enough food to convert all those carbs into fat and all that protein into excess protein into fat and to push all that fat into your fatty tissue, because even though the genes loaded the gun and you were insulin resistant, the environment didn't pull the trigger. You didn't have enough nutrition in your diet, enough calories to convert into fat. So what your body did though is you had enough insulin resistance to push the insulin levels up to encourage whatever you ate to store, but you didn't eat enough to become obese. So those people were very healthy, but they had highish levels of insulin. Compared to an obese person who's got highish levels of insulin, what's happening is that eventually they will continue to require higher and higher and higher and higher levels of insulin till their pancreas bursts and goes out. So I talked a little bit about so therefore why high fasting insulin can be a good thing if you're lean and if you're in an environment that doesn't have too much nutrition, but can be a marker of your pancreas is about to fatigue if you are obese and starting to need increasing amounts of insulin to cope with the increasing insulin resistance from obesity and the increasing insulin resistance from an ongoing high caloric diet. So I talked a little bit about insulin resistance and how, what can actually happen once you eat carbs is, I talked about the insulin going up to deal with the carbs. Your cells are resistant, so you produce even more insulin to overcome the resistant cells. The fat tissue cells remain sensitive, so all the fat gushes into the fat tissue, no problem. And it manages to overcome the resistance of the muscle and liver cells, and the sugar manages to enter those cells and have those three destinies. So converting into fat, which then gets transported to the fatty tissue, converting into glycogen, or converting into energy. Now, when that happens, you can end up overshooting, and the insulin's so high that your blood sugar drops. And so when your blood sugar drops, your body then has to produce a whole bunch of cortisol, adrenaline, noradrenaline to pull that sugar back out of the cells. And that's when you get that extreme side effects of being, of that kind of stimulated, we call it a sympathetic nervous system reaction, adrenaline, noradrenaline, and stress response, cortisol. So what are some of the markers that you might be insulin resistant? After a high carb meal, you get your sugar go up, then you get your sugar crash, and then you get your insulin go up, and you get your insulin go down, and you get your adrenaline and noradrenaline and cortisol go up. And in that phase, an hour or two after a high carb meal, after the sugar's gone up and down, the insulin's gone up and down, and the adrenaline, noradrenaline, and cortisol have gone up, they start to exert their symptoms. So if you get nauseous after a high carb meal, if your heart palpitates, if you get sweaty, if you get breathless, if you feel irritable and cranky, or if you get sleepy because there's some evidence that insulin affects the flow of neurotransmitters in your brain, then you're likely insulin resistant. If you have a waist to hip ratio for women around the umbilicus, if the waist measurement around the umbilicus is 80% or more of your hip measurement at the highest point as a woman, you could be insulin resistant. If your waist ratio around the umbilicus, around the belly button, is 90% of that around the hips, if you're a man, you could be insulin resistant. If you had gestational diabetes in pregnancy, if there's a family history of type 2 diabetes or even heart disease, stroke, or high blood pressure, if there's a tendency to put on weight in your abdomen or upper body, then all of those could be markers of insulin resistance. So the test to test for that is a fasting insulin, an HbA1c to check if you are pre-diabetic, and anything above 5.5% is often pre-diabetic, a fasting blood sugar, and a very sensitive marker is what's called a 2-hour postprandial insulin and blood sugar. So not just what you are fasting, but how high your insulin and your sugar go up after a set amount of carbohydrates 2 hours later when tested. So that's what they actually do in India. They do a 2-hour fasting postprandial. An Indian surgeon told me that. The surgeons over there are very astute at checking, because diabetes is so rife in India, are astute at checking for insulin resistance over there before they operate. So, so I just wanted to, I have actually touched on a lot of this material, but I wanted to recap it and recap what a hormone is and what insulin is and what insulin resistance is.